All right, everybody, let's get started. So assignment 2. So I've actually noticed a lot of you have submitted assignment 2, so that's great. But I did get an email on the weekend saying there's a lot of midterms and assignments due this week. Can you please move assignment 2? So I did. So assignment 2 is now due after your midterm break. Right? So the Monday after midterm break is now the due date of assignment 2. All right, so let's do the lecture. All right, we were talking about regular expressions. Oh, there's two things. So in the last lecture, there was a problem with the number of arguments to a script. So the number of arguments to a script is, in fact, stored in the variable $sign. It's stored in this variable, that one. So if you want the number of command line arguments to a script, it's $#. Right? So that's the number of arguments to a script. It's not $at. I'm not sure why $at showed up in some of the scripts. But in about 10 minutes, I'm going to show you how to find every file that has an incorrect $at in it. Right? And so we'll be able to fix those up for us in just a few minutes. OK, so we're talking about regular expressions. I'm going to switch to PowerPoint for a little bit in this lecture. Sure. OK. All right. So I showed you the following in the last class. So when you use equals tilde, that does regular expression matching inside double square brackets. Right? So this if statement tests, does that string match that regular expression? Right? OK. Now the regular expression, where is it? Somewhere. Just so. OK. It's not on the slide. OK. So regular expression is just a plain old string. So let's say it's the string ABC. Right? So that's just the string ABC. It doesn't have any special characters in it or anything like that. Then what that construct does is it tests, does the string ABC appear inside the string str? Right? So in other words, is ABC a substring of str? Right? Or in other words, if that's just a plain old string, no special characters in it, then this is saying, does str contain that string? Right? Which is normally, well, I guess not normally. Often that's not what you want. Often you want something more specific than does a string contain a substring. Right? OK. So here's a little script that you can use. It's the same script that's in the notebook. Right? This is a little script that you can use to test your regular expressions. Right? So you pass in, you type in test_regex.sh. Right? Your first argument is the string. Your second argument is the regular expression. And this tells you whether or not your string matches that regular expression. This is surprisingly handy when you're debugging regular expressions. And you're going to have to debug your regular expressions because they're actually very hard to write. Right? So this is super handy for testing out your regular expressions when you're trying to write one. OK, so the regular expressions, they use all of these funny symbols. Well, I guess funny. All these special symbols here. Right? The symbols are called meta characters. So you write your regular expression in terms of regular characters and meta characters. The meta characters control how or define how the pattern that you're trying to match is defined. Right? So we've got this. This is the caret, right? So Shift 6 on most keyboards. Right? So that's called an anchor, and so that matches the beginning of a string when used as the first character in a regular expression. Right? So if you want to know, does a string start with another string? You would write the regular expression as caret, and then the string, then the prefix that you want to match. Right? Does it start with a given prefix? Right? The dollar is another meta character inside of a regular expression. Right? So this is also an anchor. This one matches at the end of the string when it's used as the last character of an expression. So if you want to know, does the string end in, say, the string ABC, right? Then you would write your regular expression as ABC $. Right? Where $$ matches the end of your string. Right? So does your string end in the string ABC in that example? All right. Now you've got the period. So remember, the period is already a special bash character, right? So on its own, the period normally signifies Well, it signifies a bunch of different stuff in bash, right? It's the name of the current directory, right? And inside of a regular expression, right, it matches any single character, right? So if you write just a period, match any single character. Now you can combine these with the caret and the dollar, right? So you can combine the meta characters. Square brackets, those will match any character that's inside the brackets. So that's the same as the regular bash string pattern matching, right? Match any single character, right? If you use the caret as the first character inside the square brackets, right, then that will match any character that's not inside the square brackets, right? Any single character not inside the square brackets, right? You can group parts of your regular expression using parentheses. I'll show you an example of that. Now, what you often want to do with your regular expressions or when you're pattern matching is you want to match a certain number or a specified number of characters, right? Now remember, I showed you an example where we were using when we were trying to manipulate strings directly. So I tried to show you an example of how would you remove all of the leading and trailing spaces from a string, right? And I showed you that you can't actually do that if you try to use one of the replacement constructs with strings, right? Because when you match a pattern with the string replacement constructs, right, you can't match an arbitrary number of spaces, right? So if you want to remove some arbitrary number of spaces from the beginning and end of a string, that's where you can use what are called the quantifiers. So you'll want to use a regular expression plus some quantifiers. Star matches the preceding element 0 or more times. Right? Question mark matches the preceding element 0 or 1 time. Plus matches the preceding element 1 or more times. Right? Squiggly brackets, m comma n, matches the preceding element at least m times and not more than n times. Right? So if you want to specify either a specific number, say 5, or a range between 5 and 10, you can use the braces to specify how many times to match. And then finally, there's or, the choice operator, right? So that matches the expression before or after the operator. This one is confusing, so we'll get to some examples of that. All right, so let's look into some examples. The only way to learn this is to try to write some examples, okay? So here's my regular expression, hello, right? If that's your regular expression, then that matches any string that contains the string hello, right? So if your string is hello goodbye, then that matches the string hello. That matches the regular expression hello. Right? So that's this is what you want to write if you want to test for contains. Right? If you actually want to test is the string hello, then you need the anchors, right? So is this string hello? Well, it has to start with, right? So caret, right? It has to start with HELLO, and it has to end with the O, right? So that will exactly match the string HELLO. So this starts with an H, followed by an E, an L, ends with an O. Right? That's how you read that. All right? Now that period will match any single character, right? But not the empty character, right? There's no such thing as an empty character. I don't think. I think that matches exactly a single character, right? So starts with any single character, followed by an E, followed by an L, followed by an L, ends with an O, right? So that matches all of these strings, right? Plus many more, obviously, right? If your string is longer than 2, 4, 5 characters, it won't match, right? If it doesn't end with an O, it won't match. Okay, starts with an H, followed by any character, followed by any character, followed by an L, ends with an O, right? Ends with an O. So in these examples, the dollar and the caret are important, right? That matches H, any character, right? So H11LO, HAYLO, and many, many others, right? If you want to specify a single character, right, but you want it to be one of several characters, right? That's where you use the square brackets, right? So starts with an S, followed by an A, an E, or an I, right? Any one of those, and only one of those, right? Ends with a T, right? So sat, set, or sit are the only strings that match that regular expression, right? If you drop the caret and the dollar sign, that matches anything that contains sat, set, or sit, right? If you drop the dollar sign, that matches any string that starts with sat, set, or sit, right? And if you drop the caret, that matches any string that ends with sat, set, or sit, okay? You can use a range. So just like you can use a range in a regular pattern match in bash, you can also use a range in a regular expression, right? So A through Z will match any one of the characters A through Z, right? So SAT, SBT, SCT, all the way through to SZT, right? Okay. If you want to match the hyphen for some reason, right? Because you can define a range, right? If you want to match a hyphen, the hyphen has to appear at the end of the square brackets, sorry, at the beginning of the square brackets or at the end of the square brackets, right? Otherwise, bash gets confused and it thinks you're defining a range, right? So here, this will match anything that starts with an S followed by a hyphen, followed by T, right? Or S followed by A followed by T, S followed by B followed by T, and so on, right? You can use a range with numbers, right? So this will be file 0 through file 9, right? And then if you want to match the period, right? Because the period is special inside a regular expression, right? You have to put it inside of square brackets, right? So when you put the period inside of square brackets, it loses its matches any character meaning and becomes just a period. So starts with an A, followed by a period, followed by a C. So that's the string A dot C. All right, any questions so far? All right, now what about those quantifiers? So star matches, I have to look these up because I never remember them. Star matches the preceding element 0 or more times. Okay, so we have star and a anything, right? So the star modifies the thing that's in front of it, right? So it modifies the period, right? So this says match anything, match 0 or more occurrences of any single character, right? So starts with 0 or more characters, 0 or more single characters, and ends with that character, right? So starts with this stuff and ends with this stuff as well, right? So this matches any single character plus the empty string because the star means a 0 or more, right? So you get the empty string plus every other one character string, right? Sorry, that's wrong. 0 or more. What am I doing? 0 plus every other string. That's right. There we go. Right? Dot star. So 0 or more. Right? So that will match any string, including the empty string. Right? Plus means 1 or more. Right? So plus means 1 or more. So this will match any non-empty string. Right? Question mark means 0 or 1. Right? So 0 or 1 occurrences of any character. So that matches the empty string plus every string of length 1. Right? All right, so I'm going to build up how to, in the next several examples, show you how to match an integer. Right? So a lot of scripts will require a command line argument that's supposed to be an integer value. Right? In bash, those values are just strings. So if you want to validate that a command line argument actually is an integer, you need to somehow test, is this string an integer? Right? One way to do that is to use a regular expression. Right? Now the question is what does that regular expression look like? Okay, so 0 through 9 inside square brackets, right? That matches any string containing at least one digit, right? Containing at least one digit, right? So A15, right? Containing at least one, yes, A15 works, right? A1, 2, 3, 4, 5 works, 1 works, 2 works, right? So that's the start of our regular expression to match an integer value, right? Okay, so an integer value has to have at least one digit, right? At least one, right? So 0-9 followed by a plus, right? That's 1 or more, right? 1 or more digits, right? There's no anchors, So this will match any string. It's the same as the previous example. Right? Next one. So now I've got the anchors. Right? So starts with and ends with. Right? So starts with one or more digits and ends with that digit. Right? And ends in a digit. So that's any unsigned integer. Right? Any sequence of one or more digits. Right? Notice that it can be, there can be leading zeros if you want. Right? So 0001 matches that regular expression in this case. Right? If you put a minus sign in front of all that, that will match any negative number. Right? So starts with the hyphen, so negative, followed by one or more digits, so that's any negative integer. Right? Now, what if you want to allow the minus sign or plus sign in front? Right? So square brackets, right? Minus plus, right? So question mark, right? So 0 or 1 of these. Right? So I can have a minus sign, I can have a single plus sign, or I can have neither. Right? That will match. Followed by one or more digits. Right? So that's any signed or unsigned integer. Right? And then finally, if you want to, you can use the POSIX character classes as well. Right? So inside square brackets, you can use square bracket, colon, digit, colon. Right? And that's the POSIX character class for the digits. Right? So that is the same as the previous example in this case. Right? So that, these two right here, are the regular expressions that match any signed or unsigned integer. Any questions about those two? Right, you have to get used to reading and writing these because it's quite tricky to do without practice. Okay, XA, so these are the I guess the quantifiers where you have to specify an actual number. Right? So XA brace 1, right? So the brace modifies the thing immediately in front of it, so it modifies the A. Right? So starts with an X. Brace 1 means exactly 1A. Right? And then the dollar sign means the expression ends. Right? So this matches the string XA. 1 comma means one or more. Right? So this is X followed by one or more A's. Right? 1 comma 3 means 1A, 2 A's, or 3 A's. Right? So XA, XAA, and X triple A. Right? And now what about the round brackets? So the round brackets let you group a regular expression. So this is, so when I write the round brackets around ABC, right, the regular expression is ABC. Right? The plus sign modifies the thing in front of it. Right? So plus means one or more. Right? So this means one or more sequences of ABC. Right? So ABC, 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 and so on and so on and so forth. Right? Any questions? There is some discussion happening. Figure it out?
Yeah, I think so. Okay. The square brackets with like 0 through 9,
yeah.
That's like not like a digit 0 through 9, it's like multiple digits?
No, any one digit, 0 through 9. So this one here, yeah. Right? So square brackets means it match exactly one instance of the characters inside the square bracket. Right? Okay. So that's any string containing at least one digit.
So it could be like a really big number?
It could be in this case, yes. Okay. But this will match any string containing a digit, right? So it would be ABC1 will match, right? Because the anchors are missing.
Okay.
Yeah.
Thank you.
You're welcome. Any other questions? All right. Here's a little script that tests if a number is even, right? So I think we had a script that was similar to this earlier on. And that one, we took in the command line argument. We just assumed that the command line argument was actually an integer value, right? Now remember, if it's not an integer value, then when you do math with it, Bash treats that value as 0, right? So if you typed in the string ABC, this script says it's even. The previous version of the script says it's even. If you actually want to validate that that argument is in fact an integer value, then you have to write an if statement, right? So if, where is $val? Yes, so $val is argument number 1. Right? So if the value matches some integer, right? I've got the not out front. You can put the not inside the square brackets as well, right? So it's fine if you write it this way. You can also write it that way, however you like. They both work, right? So if that value does not match an integer, right, then this one complains, right, and it sends a message to standard error, right? Remember, send a message to standard error. It's greater than and 2, right, and then it exits with a non-zero status to indicate that an error has occurred. Yeah. Yeah, I'll post the lecture slides. Yeah. Sorry, I didn't put them up before class. The notebooks are almost identical to the lecture slides, though. Otherwise, it goes ahead and computes whether or not if the value is an integer, then it goes ahead and computes whether or not the value is even or not. Right. Okay, a few more examples. So this bar, I wonder if these are right. I think these are right. Okay, this bar is a bit funny. So it matches the thing. So the bar is the thing in front or the thing after it. So B bar CAT, right? So starts with, you read this as either a B or a C, right? It's not B or cat, right? It's B or C, followed by AT, and it has to end with the T, right? So that matches bat or cat. Right? Starts with an A or A. So that's every string that starts with an A. Right. Starts with an A or ends with an A. Right? So that matches any string that starts with or ends with an A. Right? Every string that starts with A. This is wrong. This one I'm pretty sure is wrong. So strike this one. I'm pretty sure in the notebooks I fixed this. Let me just switch to the notebook quickly because I'm pretty sure I fixed this one. Where is the... Okay. Whoa, sorry. Okay, here are the better examples. Okay, so A or B, right? So you have to look at the regular expression immediately before the bar. Can you see that? Yeah, you can see this, right? And you look at the regular expression immediately after the bar, right? So if your regex is A bar B, that matches any string containing an A or a B, right? Now this one, you look at the regular expression before the bar, so that's B. That's actually the starts with the B, right? So the regular expression before, it starts with the B. The regular expression after ends with cat, right? So this is any string starting with a B or ending with cat. Right? It doesn't match bat or cat. Well, it does match bat or cat, but it matches a bunch of other things as well. Yeah?
It's matching only B.
Which one? This one?
Yeah.
Anything, well. Not B, B or cat. Okay. So this one says it matches any string starting with a B. Yes, it does match. It says that the string baby is matched by the regex, starts with a B. Sorry, I can't hear you.
So I'm on regex 101, and I'm putting it back as the test string.
Yeah.
And I have the same regex that you have, but it's only selecting the initial.
Okay, I'm going to have to look at it because this, I mean, you can look at the code that this is running. Yeah, yeah, I'll have to look at it later. Okay. I remember writing this notebook and spending a lot of time testing all of these. So I'm pretty sure that bash actually matches these ones. So, there is something I didn't tell you. So there are different versions of regular expressions. So you have to check, are you actually using the same version, the same regular expression type that bash is using. Bash uses something called the extended POSIX regular expression. Okay, next one. So the regular expression before the bar starts with a B, right? The regular expression afterwards starts with a C followed by AT and ends with AT, right? So that's any string starting with a B or the string cat in this case, right? And then finally the last one, right? So this one I've got a bunch of stuff in round brackets. So the regular expression before starts with a B. The regular expression after starts with a C. That's followed by ends with AT. Right? So that's the one that actually matches only bat or cat. Right? And again, you can just edit that line and try these out and see and test them for yourself. Right? Okay, so in the notebooks, I give you some regular expressions and ask you what do those match, but the lecture slides actually tells you what they match. Boop. Okay, so if you want all the years between 1900 and 2099, then these are almost correct. You need the anchors. The anchors are missing, right? So all the years between 1900 and 2099. So when you look at this thing, you have to deduce that your regular expression it either starts with 19 or it starts with 20, right? So one way to write that is, in round brackets, 19 or 20, right? Closing round brackets, right? What's the regular expression before the bar? Well, it's 19, right? What's the regular expression after the bar? It's 20, right? So it matches either 19 or 20, right? Followed by a digit between 0 or 9, followed by a digit between 0 or 9, right? So that gives you all the years between those 2 years. If you want the months between 0, 1, and 12, right? 0, 1, and 12. So this one's fun, right? So I've got a bar here, right? So there's a regular expression in front, and there's a regular expression in the back, right? So the one in the back is a 1, 0, 1, 1, or 1, 2, right? So that's 10, 11, or 12, right? The one in front is 0, 1, 0, 2, 0, 3, 0, 4, up to 0, 9, right? So the part in front of the bar, months 0, 1 through 0, 9. After the bar, months 1, 0 through 112. Right? And now finally, your days between 0, 1 and 31. So here's another fun one. Right? I've got 2 bars now. Right? So here's 3, 0, and 3, 1. So there's 30 and 31. Right? This is 10 through 29. Right? And this is 0, 1 through 0, 9. Right? So that will give you your days between 0, 1 through 31. There are your months between 0, 1 through 12. There are your years between 1900 and 2099. So if you wanted a regular expression that matches any dates between 1900 and 2099, you have to mash all 3 together. Right? Notice that your regular expressions start to get very long. All right, let's go back to the notebook to see if there's anything else in there that I may have forgotten to cover. Oh, grep. Yeah, grep. Grep's good. Okay. So it's often the case that you want to search a file or files for a regular expression. Right? I want to know, does this file contain some string? Right? So for example, does your Java program use a loop? Use a for loop, right? Or does your Python program import some module or something like that, right? Or did you name some class somewhere in your Java program and then decided to change the name, right? If you decide to do that, then I have to change every instance of that class usage somewhere in all your other files. So I want to find all the files that now have the changed class name, right? So grep is one of the programs that you can use to search a file for a regular expression. So grep is short for Global Regular Expression Print, right? And it's one of many, many programs in Unix that uses a regular expression, right? That find command that you used in assignment 1 can also accept regular expressions. So you can search file names using a regular expression. Right? Okay, the basic usage for grep is as follows, right? So grep minus big E. You need the minus big E if you want to use the regular expressions that I've been showing you, right? So the ones that I've been showing you are these ones, the POSIX extended regular expressions, right? Normally you give grep a file name, one or more file names, and it searches those files for the regular expression that you specify. If you don't give it a file name, it reads from standard input, which is a bit unusual, but that's the way it works. Okay, so how do you use grep? So I want to find all the files, all file names that contain the word zip, right? Contain the word zip. So the zip can be anywhere in the word, right? So I want to find all the files in this directory, So in user bin, what are all the files that start that contain the word zip, right? So I use ls to list the contents of the directory. I pipe the output of ls to grep, right? Because grep can read from standard input, right? And grep is going to search for all the names, all the file names that contain the word zip, right? Now, if you want, normally that's not what you want. Normally you want to use the anchors, right? So all the ones that start with zip, right? I need the anchor, the start with anchor. All the ones that end with zip, I need the ends with anchor, right? So let's see what this prints. This prints out. So files that contain zip, it turns out there's a lot of them in Linux, right? So there's a whole whack of them. Files that start with zip, right? Files that end with zip, and you can see that the output's even nicely colored for you. Right. Okay, here's another example. So the option -n is super handy with grep because -n tells you the line number in the file where the match has occurred. Right? So grep -en, right? For I'm going to look for any line that contains the string 4, right? And I'm going to look for those files. I'm going to look for the matches in this file allwordslookup.java, right? So I've got a Java class, right? I'm going to look for all occurrences of the word 4 inside that class, right? And it prints the line number, right? So I know that on line 82 there's a loop. Right? On line 121, there's a comment that has the word 4. Right? 123, 131, 139, 148. Right? They all have loops. Right? So you can see one of the problems with using a regular expression to look for something in a piece of source code. Right? Usually, you cannot distinguish between the keyword. Right? So that indicates that there's a loop and a comment. Right? So the regular expression and grep is useful for searching the file if you're looking for some sort of construct, in this case a loop, right? But it won't find just occurrences of the loop, right? It'll find all occurrences of the string 4, right? And in general, there's no way to make your regular expression only find occurrences of the keyword 4, right? Because the grep doesn't know anything about the structure of a Java program, right? So it can't distinguish between a loop and a comment that happens to have the word 4 in it, right? So a lot of the time people will try to use a regular expression for some task, and then the regular expression will find more matches than you want, right? That's not unusual, right? Now you can try to make this a little bit better, right? So you can say, well, look, I can make this a little better because I know what a for loop looks like. Right? In Java, a for loop looks like 4, then 0 or more spaces, and then a round bracket. So you could search for that. Right? So your regular expression in that case is 4. Right? I'm going to use the POSIX character cast blank. Blank is any white space, almost any white space. It's the space and I think the tab. Right? So it's 4. The star, 0 or more, right? So 0 or more blanks, right? So 4 followed by 0 or more blanks, followed by the round bracket, right? The round bracket's special in a regular expression, so you have to put it inside square brackets, right? To actually match the round bracket. Okay, so when I run that, that's going to get rid of the comment in this case, right? But that's still not guaranteed to work because because you can just comment out a for loop and it'll still match the commented out for loop. Okay, if you know how to write HTML, then you know that HTML is made up of a bunch of anchors plus some other text, right? So if I want to find all of the anchor text, all of the anchor tags in an HTML document, you can search for that, right? So the less than sign followed by an A followed by a space, right? That will match all your anchors. I don't know if there is a my web page, is there? I don't know if there is one. Oh no, I don't have one. So you'd have to make up a web page and search that way. If you like to do crossword puzzles, then you can cheat using grep, right? So here, that thing called words, that file called words, that's a dictionary file. So it's one word per line. I don't know how big this one is. It's pretty big. So that's an English language dictionary. This regular expression, well, what does it match? Well, it starts with any character, followed by an A, followed by a K, followed by any character, ends with an S, right? So if you're ever stuck on your crossword puzzle, you can just use grep and Linux to solve your crossword puzzle for you, right? Or at least to help you. So this lists all of the possible matches for that regular expression there. Right? Again, the anchors are needed, right? If you don't have the anchors, it'll match any string containing a character followed by A, followed by K, followed by a string, any character followed by A, followed by K, followed by any character followed by S, right? Which is a lot more. Actually, how many more is it? It's probably quite a lot. Yeah, it's a lot. Okay. Oh, it's quite a few, right? Okay, so at the end here, there is a little bit more information about regular expressions. So number one, you're almost certainly going to want to find a web page like he was looking at to help you with these things, because there are a whole lot of them. Make sure that you're using the POSIX extended regular expressions when you test them out, or use the little script that we have in your CISC220 directory, right? If you want to find out more about how to write them, there are some references here. Where is it? It's this one in particular. And there's also a warning here, right? So regular expressions are like a particularly spicy hot sauce, to be used in moderation and with restraint only when appropriate. Right? A lot of programmers, when they find out about regular expressions, they try to use them everywhere, and they quickly find out that they don't work everywhere. Yes?
What does -EI and -ES do?
Yeah. Where's grep? Here. Okay. So -E, that tells grep to use the same type of regular expressions that I've been telling you about. Right? So that's the POSIX extended regular expressions. If you don't use the -E, then it just uses the regular POSIX regular expressions, which don't do quite as much as what I showed you. -N tells grep to print out the line number that where the match occurred. Yeah. There's a whole bunch of other options to grep. This is just like this is just a little taste of how to use grep. Here. This, I think it's this one. Somewhere there's a regular expression for matching email addresses, I believe. Somewhere. Where is it? I'm pretty sure it's somewhere in this set of pages. Examples? And email addresses. Now, you would think that an email address isn't that complicated, right? It's something at something. But it turns out there's a whole lot of rules, right? So if you scroll to the bottom of this page, that thing there is the regular expression that you would need. I think it's that one there. That actually matches all possible legal email addresses, right? I don't know who came up with that or how much time it took them to come up with that. I couldn't come up with it, and I don't expect you to be able to come up with it either, right? But regular expressions they're often useful, but they often don't quite do everything you want them to do, right? But they are useful. All right, any questions on regular expressions? Okay, let's move on to arrays. Arrays in Bash, like everything else in Bash, are strange. So Bash has a one-dimensional array, right? It's indexed using an integer index, like the ones you're used to, right? So you would think starting at 0, right? You would think starting at 0. They also have one-dimensional associative arrays, which you know as dictionaries in Python. Right? If you've taken the 124, then it's similar to a map in Java. Right? We're not going to use the associative arrays in this class. You can if you want to. I'm not going to tell you about them. If you have bash 4.3 or higher, you have associative arrays. Otherwise, you have regular arrays. Arrays are like any other variable in bash. They're created automatically when you first use them. Right? If you want to, you can use declare to declare them as well. So there's a command called declare that you can use to declare variables. Often, it's easier to use the round brackets to make an array. Right? So in a single pair of round brackets, that actually creates an array. So I'll show you how to do that in a minute. All right, so like I said, bash arrays are funny. So they're zero-based. Right? In other words, the lowest index that you can use in a bash array is 0, although that's not quite true as well. Right? So 0 is the smallest starting index. It doesn't mean that your array starts at index 0, which is weird. So there's no requirement that you start filling in the array starting at index 0. Right? There's no requirement. So you can make an array and start filling it in at index 100 if you wanted to. Right? There's nothing from stopping you from doing that, and bash won't complain. Right? Bash doesn't even care if your array indexes are contiguous. So you can start at 0 and then go to 5 and then go to 12 and then go to 13 and then go to 22. Everything in between, it's not there. Right? So bash doesn't care. Right? Okay, so like I said, you make an array when you first use the variable, and if bash can determine it's an array, it will make an array for you. Right? So if you just start writing something like a square bracket 0 equals some string, that makes an array for you. Right? So the a is now an array. Right? The thing inside the square brackets is the index. Right? Now here's b. Right? Square bracket 1 equals goodbye. So that makes an array b. Right? The only element in the array is the string goodbye, and it happens to be sitting at index 1 of that array. There's nothing at b0. Right? This one's even weirder, right? So I can make an array C, and I can start at index 100 and assign it a value. There's nothing at indexes 0 through 99. Right? This is all perfectly legal in bash. Okay? It's weird. It's just the way it is. Now, how do you get the value of an element? You might think that I would write $ array name square bracket, right? Index. Right? That doesn't work. Right? This doesn't work. Right? If you want to index, if you want to get an element out of if you want the value of an array element, you must use the braces. Right? You must use the braces. So if I want the element at index 0 of a, right? $ brace a square bracket 0 closing brace. Right? If you want the thing at index 1 of b, you got to put the b square brackets 1 inside braces. Right? And same with the c. Right? That does something odd. Right? That does something very odd. Okay, if you want to make a variable using declare, you can. Right? So there's this command called declare. If you pass in -a as the option, that tells the declare command to make an array variable. Right? So declare -ax makes a variable ax that's supposed to be an array. Bash doesn't actually care if you use it as an array or not. Right? So declare doesn't actually do anything. Right? Declare -ay says make a variable y that's supposed to be an array. Again, you don't have to use y as an array. Right? Similarly with z. Right? There is no typing in bash. Right? There is no strong typing in bash. So you can say declare -a, but you can use it as a regular string. Right? And again, you can do this weird indexing thing where you don't start at 0. Okay, round brackets are often useful. And there'll be another example of this in the next class. Right? So as soon as you put something in round brackets, bash makes an array to hold the elements inside the round brackets. Right? So array 1 equals hello. So that makes an array called array 1. The element at index 0 is the string hello. Right? If you have hello space goodbye, that makes an array who has 2 elements in it. Right? The first element is hello, the second element is goodbye. Right? If you want to, you can assign indexes with this notation as well. Right? So round brackets, square bracket 1 equals goodbye, means make an array called array 2. Right? The element at index 1 is the string goodbye. There is no element at index 0. Right? This one's even weirder. Right? This makes an array called array 3. The element at index 100 is weird. The element at index 0 is weirder, and the element at index 1 is weirdest. There is no element at index 2, 3, 4, 5, 6, 7, 8 through 99. So this is fine as well. Often what you see is a bunch of space-separated strings with round brackets around them. So that makes an array where each string is a separate array element. Okay, let's, yes, I think that's definitely a good place to stop. So let's stop there and we'll pick this up on Wednesday.